Hello, this is Mrs. Smith, and today I'm going to show you how to run the wheel and axle lab. So come on over. You should have your wheel and axle lab loaded on your Chromebook, and it starts out asking what is the diameter of the wheel. Okay, well, to get that, you're going to come over to your device, and the big circle is going to be your wheel. The small one is going to be your axle. So to get the diameter of the wheel, you take the string and you run it all the way around so that we're doing diameter. Okay. To get the diameter of the wheel, all you need to do is run your string across like this. Bring the camera over here so they can see it. Okay. Then you can bring this over and you're going to record your answer in centimeters. Okay. This one looks like it's 11 centimeters. Okay. And then to get the diameter of the axle, you're going to come over and do the same thing, okay, because the diameter is the distance across. Okay. And then you record it in centimeters. And it looks like it is 7 centimeters. Then it's going to tell you to attach a resistance weight to the string attached to the axle. Okay? You're going to take your resistance weight, and we're using this as your resistance weight. You need to have a paper clip on it. And your axle, again, is a small one. You've got it set up so that you've got a loop. Okay. And use your fingers to turn the wheel based on where the applied effort and resistance are located. Identify the distance traveled by both forces during one full revolution. Okay. So here I'm going to do one full revolution, and I have this, right? Okay. So when you want to find out how much linear distance has been traveled, you take your string and you pull it out, and this will tell you the linear distance traveled. You just have to measure it. This is the linear distance traveled by the resistance force because the resistance weight is attached to it. And it asks for the linear distance traveled by the effort force during one revolution. And if you bring this back, you're better off if you've got, when you start, if you have them both lined up to the same one. Okay. So then when I do one revolution of the axle, okay, you see I also do one revolution of the wheel. So my linear distance traveled on the wheel, you're going to measure from here to here. Okay. And again, this is the resistance force because you've got the resistance weight on it. This is the effort force because that's what you're turning. The next question, the next question tells you to take the weight from the axle and move it to the wheel. So now your weight comes over here, and you're going to do the same thing. But now the wheel becomes dr and the axle becomes de. Okay. And if you can follow that, the rest of it's quite easy. Okay. Now you're going to do the same thing with the force sensors. It tells you to wrap the resistance weight around the axle using your string. So you're going to take this back to the axle, and I'm going to cheat a little bit and just get it wound up. Okay. So now I have my resistance force on the axle. Before you do that, remember to use your sensor and figure out how much the resistance force weighs. So I'm zeroing out the sensor, and I'm going to put it here, and I'm getting about 2.95 newtons, 2.93 maybe. So FR is 2.93. Okay. Now what you have to do on this one, it's a little bit complicated. You want to see how much force it takes to balance it. So you're going to wrap your string around the wheel, and then you have to zero your sensor again. So I'm going to come in and zero it. And notice how I'm pulling the opposite direction to keep it balanced. I want to see what my resistance force is to balance it. And this appears to be 2.3 newtons. This becomes Fe. Okay, Fe is 2.3 newtons. So that's what you're going to record here. Then it tells you again to now wrap the weight around the wheel using the string. So you're going to move your resistance force from the axle to the wheel. The value of the resistance force hasn't changed. Okay. Now you have to balance it using this right here. So now your effort is going to be applied to the axle. And I'm going to zero out my sensor again and apply it here. Okay. So I have roughly 2.1 newtons effort force when the resistance force is applied to the axle. Or I'm sorry, when the resistance force is applied to the wheel. Okay. And that's all we're going to talk about today. Thank you.